Anyone, please?
7 times 3 plus 12.
Indeed.
12 plus
We have to,
7 times
yes, exactly. That's exactly it. These are identical. We only use the commutative law of multiplication, and we created an equivalent expression. Very good. Good, let's continue. Evaluate each of the following, simplifying your answer completely. So we have the absolute value of 2 plus negative 7, and then 1/3 divided by 3, and then the next and the next and the next. Good, so let's work on the first one. Okay, 1 minute. You should take like a blink. Let me know. So what do we have to do first here in the first problem? Anyone?
Take the absolute value of -7, that's 7.
You cannot do that. The absolute value is outside. We're not allowed to apply it to anything else but one single number. You cannot distribute. This is not the distributive law or anything like that. I have to perform these operations first. I cannot apply the absolute value till I get to it. I didn't get to it yet. So what do we get here? The absolute value of?
Would that be -5?
Very good. And the absolute value of -5 is?
5.
Good. Let's divide 1/3 by 3. Remember what we need to do in this particular case. It is better to rewrite this in this format. So the numerator is 1/3 and the denominator is 3. But 3 is the same with 3/1. Remember, fractions are the same. I mean, integers are the same with 3/1, 5/1, -3/1. It doesn't matter how you present it. It's still the same thing. So it's 1/3 multiplied by 1/3. The same thing here. I write the fraction from the top and I change it. I change the division to multiplication of the by the multiplicative inverse of the denominator. Only now I'm allowed to multiply, and I multiply and I get 1/9 in both cases. If you prefer this notation is fine. If you prefer this notation, whichever is clear to you. Then we have a very simple example, which is 3/5 minus 2/5 plus 1/5. So what do you think about this? What would you do? Any suggestions on this problem? Yes, we only have to copy the least common denominator, which is the same. And here we are allowed to copy the numerators. 3 minus 2 is 1, 1 plus 1 is 2. And this is the final answer. Good. Moving on. Here's the next question. Represent 0.02 as a simplified fraction. Okay? So how would you represent 0.02? Actually, this is over 1, but how would you present it as a simplified fraction? How will you start? Can anyone tell us or put us on the right track?
2
Well-
over 100?
Yes, indeed. 2 over 100. Why 100? Because there are 2 decimal digits. And now we have to simplify it to the fullest.
Divide by 2?
Yes, so it's 1 over 50, and this is it. Any questions on this? Okay, moving on. Here we are asked to round each number to the nearest tenth. Tenth means the first decimal digit. So I'm going to copy both, 0.2501 and negative 0.2051. Good. To the nearest tenth. So this will be approximately, nearest tenth is this digit. The first number will be approximated to anyone, please? Please give it a try, the first one. What will you say? It's approximately what?
3.
You mean 0.3. So because the hundredths digit is 5 or more, we have to increase the digit prior by 1. What about the second one? Negative point?
2.
That's it. Because the following digit, which is the hundredth spot, is lower than 5. 0, 1, 2, 3, or 4. Therefore, that's the correct answer. Perfect. Good. Perform the following calculations. So here we have 1.234 multiplied by 0.001. And the other one is 1.234 divided by 100. Okay, let's start with this one, with the first one. With the second one, with the division. Here's why I want to start with this. Because when we divide by 100, what we really do, we move the decimal point 2 spots to the left. 1, 2, which means 0.01234. Now, when we multiply by this, it's the same thing with division or multiplying by, Remember how we changed this number into a fraction? It's 1 over 1,000. Exactly what we did here. We had 0.02, we had 2 decimal digits, we put 2 over 100. Here I have the decimal digit, and we have 3, so it's 1 over 1,000. It's the same thing as here, except instead of moving the decimal point 2 spots to the left, I have to move it 3 spots to the left. 1, 2, 3. So I have 0.001, 2, 3, 4. Is this clear? Do we understand this, or do we need more examples, or we need to explain more? So when I multiply by 0.001, yes, I can use the calculator and I'm done. But we have to understand this and how it's very simple, really. So I change this into a fraction like we did before. It's 1, 3 decimal digits means 3 zeros. Every time I divide by a power of 10, like 100 or 1,000, all I have to do is move the decimal point from wherever it is. It may be here. It may be here. It doesn't matter. In this case, 1, 2, 3. 1, 2, 3. So I have 2 zeros in front of 1. Here I divide by 100, which means I have to move the decimal point this way, 2 decimal digits. 1, 2. Point or 0.01234. Is this clear? Okay, nobody's saying anything, so I'm not sure. Is it a yes? Is it a no? Do I move on? A cab charges 65 cents per mile traveled plus 2.25 starting. They only want us to present an expression, an algebraic expression that depicts this situation. 65 cents per mile plus 2.25 to start. Write an expression for the total charge. How will I write that? They turn the meter on, but that's $2.25. And then 65 cents per mile. How do I write an expression that depicts this situation? Anyone would like to give it a try, please?
Is that gonna be 0.65x plus 2.5?
Yes, 2.25. Yes, I put an extra 0 by mistake. Forgive me. It is 0.65, 65 cents, times the number of miles. Excellent. Thank you very much. That's perfect. 0.65 times the number of miles plus $2.25. This is the total cost, or whatever we pay. Excellent. Thank you. Moving on. Perform the following calculations and indicate. So we are asked to find 1.4 minus 2.1, and then negative 0.5 squared, and then 1.7 plus 0.3 times 0.5. Okay, so let's work on this before we move on. Always establish the sign first, because then it's easier to calculate. What is the sign of that outcome of 1.4 minus 2.1?
Negative.
Yes, since it is negative, on the side, you only need to calculate 2.1 minus 1.4. Remember, when we add and subtract, the decimal digits have to line up. No matter how many digits, decimal digits any of the numbers has, it doesn't matter. They have to line up. 4 from 11 is 7, and 1 from 1 is 0. So then I got the final answer. Okay, now, what is the sign of this outcome? Negative 0.5 squared.
Negative.
Yes, because we have to square 0.5 and then multiply by negative 1. Here's how I multiply. It happens in this example that the decimal digits line up, but it's not required for multiplication. It is required for subtraction, but not for multiplication. But for multiplication, they have to end up correctly one under the other. That's all that matters. 5 times 5 is 25. There is nothing else I can multiply. And now I have to count the number of decimal digits. 2. The decimal point is here. I have to move it 2 spots because I have 2 decimal digits. So the answer is 0.25. Always remember, when you multiply 0.5 by 0.5, you get a much smaller number, right? 0.5 is 50 cents. When I multiply 50 cents by 50, which is not possible because I cannot have cents squared. It's a silly example. But what I'm saying is, when you multiply 0.5 by 0.5, you get 0.25. How come? Very simple. Here's why. You know that 0.5 is 5 over 10, which is 1/2. So basically here, I'm multiplying 1/2 by 1/2, and I get 1/4, which is a quarter. It makes sense. Okay, I disregarded the sign, of course. So now let's work on this. 1.7 plus 0.3 times 0.5. So let's see what we get on this one. 1 minute, please. Please, let's work on this. What operation will you perform first before we look at it, before we work on it together? Which operation needs to be performed first? For sure.
The multiplication.
Exactly. That is more powerful than addition. Do not attempt to add 1.7 to 0.3. That's not possible because this is a more powerful operation. And remember, when we multiply 0.5 by 0.5, we get 2 decimal digits. The same thing will happen here. We multiply 0.3 by 0.5. 5 times 3 is 15, but now I have to count the decimal digits. There are 2. So I have to move the decimal point 2 spots to the left. So I have 1.7 plus 0.15. Now I can add. Now, when I add them, I have to line up the decimal point. This is a must. When I add and subtract, I have to line up. And if anything is missing, it's fine. It's fine to put a 0 there. After the decimal digit, after the last digit, you can put as many zeros as you want. Nothing will change. But because I'm adding them, I have to line up the decimal point. Here I don't have to. It just happened at the end, and they have at the end spot, the same spot, and they have this the decimal digits lined up, but they don't have to be. So here I have a 5 and an 8 and a 1, and I copy the decimal point. So this is 1.85. Any questions? Okay, let's work on the expressions. You have to use the order of operations forever the next 100 years. I don't know what's going to happen after 100 years. Maybe AI will take over. I don't know. But definitely for the next 100 years, you have to use the order of operations at any point in time. It's your best friend. The order of operations just became your best friend forever. Okay, so let's work on these problems. 6 plus 3 quantity w minus 1. Then the next one, 1/2 4x minus 6. And then x minus 0.4x. Good, so let's work on the first one.